What is infinite? This is the only question that humanity will perhaps ask as far as it is, but never able to answer. Of course, I've been thinking about infinite for a long time and I have something to tell you about infinite. Let's do a thought activity together. The Cambridge Dictionary says for infinite, boundless, oversized or wonderful. Do you think it's just that? I don't think so. Infinite is such a thing. Philosophers, mathematicians, physicists tried to answer this question for centuries. Some of them devoted their life on this. Some of them thought it was not necessary to try to understand infinite at all. For example, French philosopher Descartes. Let me tell you about known beginning of thoughts on infinite. The ancient Greeks approached infinite in a philosophical way. The first sources about the infinite are found in Anaximandros, a pre-Socratic philosopher. Anaximandros used the word apeiron to denote the infinite. Apeiron, which Anaximandros chose as arche, in other words as the beginning, it means unlimited, indeterminable in Greek. In the philosophical sense, it means that everything arises from itself and disappears in itself. What is not here, cannot be defined, cannot be determined, is unlimited. Anaximandros is a very important person. He is the first person to try to explain the formation of the universe on the basis of rational thought. There is an underwater mountain which is named after him in Turkey. Mathematical uses about the infinite also appear in ancient Greece, where? In Zenon of Elea, one of the important philosophers of the Elea school. Zenon is a master of logic. You have all heard of the Achilles paradox, perhaps one of the most important propositions in the history of philosophy. For those who don't know, let me talk about the Achilles paradox right away. The Greek hero Achilles will race with a turtle. Achilles is a pretty good runner, but I can't say the same for the turtle. The turtle will start this race a little distance ahead, and of course Achilles will faster than the turtle. Both will run at constant speeds. Zenon took this race logically and argued that Achilles will never surpass the turtle. It's because Achilles will always have a distance to run. Think about it. When the Achilles reaches the position where the turtle starts racing, the turtle will have advanced a little. When Achilles reaches this distance, the turtle will have advanced a little bit more, and this chase will continue. Of course, velocity is a vector quantity. We all know that at some point Achilles will catch the turtle, and after a moment Achilles will surpass the turtle. In this paradox, the purpose of Zenon is to suggest that movement is impossible in terms of logical thinking. I'm planning to create a content about Zenon and his paradox, but it's subject of another story. When I talked about the infinite and mathematics, I can't close this topic without mentioning ancient India. Surya Pranapti, an Indian mathematical work, divided all numbers into three groups as countable, uncountable and infinite. These groups are also divided to subgroups, but I won't tell you about them because these subgroups need very deep investigation. We talked about the historical journey of infinite. Let's look at the infinite in mathematics. The infinite taught in math classes is often fictional infinite and has a symbol we all know. English mathematician John Walsh created this symbol in 1655. When we say mathematics are infinite, we think that infinite is a number that can be reachable for some way, but this is extremely wrong. Suppose we start counting in the set of integers containing infinite numbers. Let's count in the positive or negative direction according to the rule we want. There will surely be another number after the last number we counted. Even if we keep adding or subtracting endlessly, we cannot reach infinite. In fact, we can create infinitely many infinitesimals with numbers. For example, the set of positive counting numbers has infinite elements. Also, negative counting numbers have infinite elements. A question for you. Is the total of positive counts are bigger or is the total of negative counts are smaller? Don't forget to write your answer as comment. See, it's fun to think about infinite. Shall we make things a little more fun? Let me tell you about George Cantor and concept of cluster. Cantor, along with other scientists, developed the first infinite flame zero in the 19th century. This modern mathematical view is concerned with cardinal infinities. In the mathematical literature, cardinals are used to represent the quantitative size of cluster. In finite sets, the cardinality will of course be a natural number. However, in infinite sets, transfinite cardinal numbers are using because there is no natural number that can describe the numbers of elements. Let me ask you one more question. Do you think all the infinite sets have same cardinality? I'm waiting for your answer. Let's look at the relationship between physics and infinite. For me, physics cannot work with uncountable quantities. An infinitely distant and infinitely large object is not possible. If there were such an object, the result of all calculations will be infinite and all theories will be difunctional. For example, the gravitational force of a planet with infinite mass will be infinite, and this is not observable. Despite this, we can also find infinite in physics. Generally, the concept of infinite is used for convenience in calculations and theories. There are also theoretical situations where the result is infinite. For example, black holes. Newton's law of gravitational force and Coulomb's electrostatic law will give its infinite value in certain situations. Apart from physics and mathematics, infinity has an important place in fields such as cosmology, logic, and computers. In the end, isn't the concept of infinite still a bit abstract? I think infinite is an abstraction where an infinite quantity of concentrate finites come together.